So here's the code from the last screencast where the bird can do two different things. If the game state is playing, then it will fall with gravity by changing the acceleration at which it's falling by 0.5 pixels per frame. Or if the game is paused, we are cycling through an angle, increasing this number by 0.1 every time, putting that through the cosine function, which returns a number between -1, 0, and 1, or -1 and 1, and multiplying that by 20 and then adding that to the middle of the screen so that it hovers in the middle of the screen. The one behavior that we didn't do in the last screencast was jumping. And it's very simple. There's only two pieces that need to happen here. And I'll just go through that really quickly. This isn't the only way to do it, so if you did it differently, totally fine. But this is how I did it. So you want to have Flappy jump when you tap. So in order to do that, we need to add some code to the touch started, which is the function run when the user's finger touches the screen. Touch started does one thing already, and that's when the game is paused, it sets the game state to playing. Now when the game is playing, we want it to make the bird jump. So we can do something here and say if game.state is playing, do something. But what do we do here? Well, how does the bird jump? How does jumping work? We talked about acceleration being a distance over time over time. The acceleration due to gravity is an additional 0.5 pixels per frame every frame. Well, if we want it to go upwards, we want the acceleration to be in the negative direction. And we probably want the acceleration to be faster than gravity because otherwise gravity would cancel it out. If we had an acceleration of -0.5, that would be going up because up is negative or up is towards 0. That would be going up, but then gravity would cancel it out. So to get a sense of how much we want to accelerate upwards, it needs to at least be more than 0.5. So let's play with some numbers here. Let's comment out the gravity for a moment, but we're going to use the acceleration thing. If we refresh the page, we start playing, the acceleration is 0, it's not moving anywhere. If we make the acceleration negative, it will move upwards. And it will move upwards continuously. But again, if we were to just have negative and positive, that'll cancel it out. So we can look at something like maybe I'm going to use 3 for a minute because that's what I played with before. So it goes up pretty fast. The thing is, we don't want to set the acceleration every frame for this. We want to set it once. We want to set when you jump, set its acceleration, its velocity in the negative direction to 3, and we can do that down here if we still have access to the bird's y acceleration down here, and we can set it to -3, and that's really actually all the code. Maybe -3 is not enough though, because we have to jump a lot. It's not offsetting the acceleration enough. So let's maybe make it 6. Now it's got some bounciness to it. It still falls pretty fast. That might not be the number we want, but it's a good start. So that's the whole bird. The one thing I might do, there's a couple things I might do differently. One of them, this is a lot of code to put down here, really far away from the rest of the bird. You can add a function, just like we call bird.draw here. Let's make a bird.jump function. And let's move the acceleration changing code into jump, only instead of bird, we're going to call this, because inside the bird's jump function, it can refer to itself with this. And then down here, we can call bird.jump, and it's a function, so we just call it. And that should have the exact same result. Yep. And then the other thing I would consider doing is looking at all these numbers. There's 0.5, there's an angle, there's this amount that we hover by, there's this jump. There's a bunch of numbers here. And when you see numbers that are kind of arbitrary, and really any number except 0 and 1 is probably arbitrary in most programming, you might want to create a variable to store those. And just like we created these all caps variables for game states, let's create all caps variables for these other ones, just again to indicate that these are things that shouldn't change terribly often or ever. So instead of changing the y acceleration by a random number, let's change it by gravity. And then that's this code. This line of code is a lot more obvious in what it's trying to accomplish. Let's change the angle amount to a variable and say we're going to have it hover by about that much every time, or move by that much every time. Let's change the hover distance to a variable. And finally, let's change the jump distance, or jump acceleration to be more acceleration. I'm going to make it even bigger. Did I spell acceleration right? I can't even tell. Jump acceleration to that. So now we have a bunch of variables, and what's cool about that is that as you're playing with the game, and you're like, actually, I think I want gravity to be a little bit stronger. It's not quite doing enough. Then you just come up here and just do 0.75. It's really well documented code. See, now it moves just a bit faster, but still usable. And so the next screencast is going to talk about making another object for the obstacle that has a lot of these same properties. It will have an update and a draw method. It'll have a x and y position. It won't have acceleration or angle though, because it will move at a constant speed and it doesn't turn. But you're going to probably have a lot more variables that you configure to kind of tweak the game. And so we're going to cover that in the next screencast. And there's the whole bird.